Hi everyone, thanks for viewing my earlier videos related to the cosmology. Now I am moving ahead to a Greek cosmology. I request you to kindly like, comment and subscribe. Thanks. Greek cosmology is wide and despite the universe and the world as having a limit both on its sky and the ground. The sky limit is known as heaven of heavens and its opposite end which lies beneath all the world is the underworld. The heaven and other realm above it are sustained by the pillars of heaven while the underworld and the rest of the world is held together by the pillars of earth. Earth and above. Earth, known as Midgard, is Norse mythology. Earth is the central realm, place, or location in Greek mythology, being the middle point between the heavens, inhabited by the Olympian gods and the underworld. Firmament with the stars. Location in which the stars, sun, the planet, and the constellations are located. Ocean of heaven, created and ruled by the Titans Oceanus and Thetis. It is a great river encircling the earth, which was believed to be a flat circle. This ocean was inhabited by nymphs known as the Oceanites, which are Oceanus and Thetis' daughter, and the god of all the streams on the earth were their sons. Heaven of heavens, the highest location in the Greek cosmology. Pillars of heaven, supported by the Titan Atlas. These pillars hold the heaven. Under the earth is the underworld, also known as Hades, in the realm where the souls of the dead go and is ruled by Hades. Pillars of earth, also supported by Atlas. These pillars hold the earth. Primeval ocean, cosmic ocean which surrounds the earth and its pillars. The sphere of the world. By the 5th century BC, it was widely accepted that the earth is a sphere. This is a critical point as there is a widespread misconception that the ancient people thought the earth was flat. This was simply not the case. In the 5th century BC, Empedocles and Anaxagoras offered arguments for the spherical nature of the earth during the lunar eclipse. When the earth is between the sun and the moon, they identified the shadow of the earth on the moon. As the shadow moves across the moon, it is clearly round. This would suggest that the earth is a sphere. Measuring the size of the earth. Lunar eclipse also allowed for another key understanding about our home here on earth. In 3rd century BC, Aristarchus of Samos reasoned he could figure out the size of the earth based on the information available during the lunar eclipse. The diagram of the right illustrates the translation of the work. The large circle is the sun, the medium circle is the earth, and the smallest circle is the moon. When the earth is in between the sun and the moon, it causes the lunar eclipse, and measuring the size of the earth's shadow on the moon provided the part of the information he needed to calculate its size. Aristotle's Elements and Cosmology. Aristotle argued that there were four fundamental elements: fire, air, water, and earth. In Aristotle's system, there was no such thing as void space. All space was filled with some combination of these elements. Aristotle asserted that you could further reduce these elements into two pairs of qualities: hot and cold and wet and dry. In Aristotle's Cosmology, each of these four elements, earth, water, fire, and air, had a weight. Earth was the heaviest, water less so, and air and fire the lightest. According to Aristotle, the lightest substance moved away from the center of the universe, and the heavier elements settled into the center. While these elements attempted to sort themselves out to achieve this order, most of the experience involved mixed entities. The wandering and fixed stars in the celestial region. In contrast to the terrestrial, the celestial region of the heavens had a fundamentally different nature. Looking at the night sky, the ancient Greek found two primary kinds of celestial objects: the fixed stars and wandering stars. Think of the night sky. Most of the visible objects appear to move at exactly the same speed and present themselves in exactly the same arrangement night after night. These are the fixed stars. They appear to move all together. Aside from these were a set of 9 objects that behaved differently: the moon, the sun, the planets, Mercury, Venus, Mars, Saturn, and Jupiter. Each moved according to a different system. For the Greeks, these were the wandering stars. In this system, the entire universe was part of a great sphere. This sphere was split into two sections: an outer celestial realm and the inner terrestrial one. The dividing line between the two was the orbit of the moon, while the earth was the place of transition and flux. The heavens were unchanging. Aristotle postulated that there was a fifth substance, the quintessence. That was what the heavens were made of, and that the heavens were a place of perfect spherical motion. The unchanging celestial region. In Aristotle's world, in the whole range of time past, so far as our heritage records reach. No change appears to have taken place either in the whole scheme of the outermost heaven or in any of its proper parts. It's important to keep in the mind that in Aristotle's time there simply were not extensive collections of observational evidences. Things that looked like they were moving in the heavens, like comets, were not problematic in this model because they could be explained as occurring in the terrestrial realm. This model of the heavens came with an underlying explanation. The celestial spheres were governed by the set of the movers responsible for the motion of the wandering stars. Each of these wandering stars was thought of have an unmoved mover, the entity that makes its move through the heavens. For many of the Greeks, this mover could be understood as a god corresponding to any given entity in the heavens. Ptolemy's circles on circles. Claudius Ptolemy created a wealth of astronomical knowledge from his home in Alexandria, Egypt, benefiting from hundreds of years of observation from the time of Hippocrates and Exodus, as well as a set of astronomical data collected by the Babylonians. Ptolemy developed a system for predicting the motion of the star that was published in his primary astronomical work, Alchemist. Ptolemy's success at synthesizing and refining ideas and improvement in astronomy helped make his Alchemist as so popular that earlier work fell out of circulation. Translated into Arabic and Latin, the Alchemist became the primary astronomy text for the next 1,000 years. Ptolemaic data. The Alchemist is filed with tables. In this sense, the book is a tool one can use to predict the location of the stars compared to earlier astronomy. The book is much more focused on serving as a useful tool than as presenting a system for describing the nature of the heavens, trying to accurately predict the place of the stars over time, resulting in creating a much more complicated model. The Ptolemaic model. By the time of Ptolemy, the Greek astronomer had proposed adding circles on the circular orbits of the wandering star, the planets, moon, and the sun, to explain their motion. These circles on circles are called epicircles. In the Greek tradition, the heavens were a place of perfect circular motion. So the way to account for perfection was with the addition of circles. This resulted in disorienting illustrations. To escape the complicated nature of this extensive number of circles, Tomley added a series of new concepts. To accurately describe planetary motion, he needed to use eccentric circles. With the eccentric circles, the center of the planet's orbit would not be Earth, but would instead be some other point. Tomley then needed to put the eccentricals on another set of circles called difference. So the planets moved on circles that moved on circular orbits. Tomley also needed to introduce equants, a tool that enabled the planets to move at different speeds as they moved around these circles. The resulting model was complex, but it had extensive predictive power. Tomley and Aristotle's cosmic legacy. Tomley came to represent a mathematical tradition, one focused on developing mathematical models with predictive power. Aristotle came to be known for putting forward the physical model of the heavens. Tomley was also interested in deploying this model of the heavens to describe its physical reality. However, his most important work was the mathematical models and data he used for predicting the motion of heavenly bodies. For a long time, his name was synonymous with the model of the heavens. Thank you, and here we end the Greek Cosmology notes. Thank you. Thanks for watching this video.